Hello there, and welcome back to Sleepy Science Stories. I'm glad you're here, resting, listening, perhaps already lying down under a soft ceiling or beneath a dim night sky. Let the noise of the day fade into distance now. The world can wait. For the next little while, you and the universe will breathe together. Take a slow breath in and let it go. Feel your weight gently sink into the surface beneath you. Gravity, the quiet hand that holds you, is already here, guiding your body toward stillness. You don't have to fight it. Just let yourself fall, slowly, safely, into rest. The same force that shapes the stars is holding you, even now. Imagine yourself drifting above the earth, high enough to see its curve, yet close enough to feel its pull. The oceans shimmer beneath you, their tides moving to the moon's rhythm. Beyond them, space unfolds, not empty, but alive. You see ripples of light, waves of time, gentle bends where mass has written its signature across infinity. This is the architecture of spacetime, a vast, invisible web where everything, you, me, every star, finds its place. Tonight, we'll explore what gravity truly is, not just a pull, but a pattern. We'll travel from Newton's apple to Einstein's equations, from falling stones to galaxies swirling in curved geometry. We'll listen to gravitational waves, tiny tremors of creation, and stand at the edge of black holes, where time itself hesitates. You'll learn how mass and energy shape reality, how light bends, and how even silence has weight. So close your eyes now. Let the mind drift as we begin our journey, softly, fact by fact, through the hidden architecture of the universe. This is gravity, the architecture of spacetime. And these are your 101 Sleepy. The first force we ever feel. Before we open our eyes, before we speak, before we even understand the world, there is gravity. It's the first invisible hand that greets us. Gentle, patient, inevitable. It holds our bodies to the ground, cradles the oceans in their basins, keeps air wrapped around the earth. Gravity is not loud or violent. It is quiet, constant, and ever-present. Every step we take, every breath we draw, happens inside its embrace. From the moment we are born, gravity teaches us the meaning of down, not just as direction, but as belonging. Even in sleep, it holds us softly against the turning earth. You may never see it, yet it shapes every movement you make. It's the silent companion of existence, guiding everything that has weight, including our thoughts, drifting slowly under its calm pull, the pull that holds us together. Gravity doesn't just pull us down, it gathers everything that exists into unity. The you to the floor also binds the stars into galaxies and galaxies into clusters. Without it, atoms would drift apart, planets would unweave, and light would travel endlessly through a fractured void. Gravity is the universe's way of saying, stay close. It turns chaos into order, dust into worlds, clouds into suns. It binds your feet to the earth, but also ties your atoms to ancient stars. You are held by the same pull that shaped the Milky Way. So when you feel weight pressing gently beneath you, remember, it is not just mass or matter, but the quiet harmony of cosmic belonging. The same force that keeps you grounded also connects you to everything that ever was. Every object curves space. Every particle with mass, from a mountain to a grain of sand, bends the fabric of spacetime around it. Imagine space not as emptiness, but as a vast elastic sheet. When something rests upon it, a planet, a star, or even your body, the sheet dips slightly. That dip is gravity. The more massive the object, the deeper the curve. When other things move nearby, they follow the natural slope of this bend, like marbles spiraling toward a hollow. This is how Earth orbits the sun, how the moon circles Earth, and how light bends near stars. Even your presence makes a tiny indentation in the geometry of reality. You are not just in space, You shape it ever so slightly. Spacetime just a little. You are not separate from the cosmic fabric. You are part of it. The bed beneath you bends with your mass, and spacetime adjusts, ever so gently, to include your presence. If we could see the world through Einstein's equations, you'd appear as a small valley in the four-dimensional landscape of the universe. The curve you create is tiny, unimaginably small, yet real. Every mass, no matter how humble, participates in shaping reality. This means that when you rest, the universe literally folds itself around you. You are not a guest in the cosmos. You are a feature of its design, one ripple among countless ripples that together compose the architecture of existence. Gravity is geometry, not force. For centuries, we thought gravity was a pull, a mysterious action that reached across empty space. But Einstein revealed something deeper. Gravity is not a force at all, but the geometry of the universe. Space and time are woven together into a single fabric, and mass tells that fabric how to bend. What we feel as weight or fall is simply the way we move through that curvature. When you drop a stone, it doesn't fall because Earth pulls it. Reality. It is reality's shape. The universe curves, and everything follows. The sculptor of stars and planets. Without gravity, there would be no stars, no planets, no galaxies. After the Big Bang. Patient artist, shaping creation not with hands, but with time. Every hill, every moon, every beam of light exists because gravity chose to keep the universe together rather than let it drift apart. But Newton's model was incomplete. It could not explain how that pull worked or why light itself bent. Then Einstein arrived, and the picture changed. He saw that space and time were not passive. Thus, Einstein showed why. The universe became not a machine of forces, but a flowing, self-shaping fabric of geometry. The apple and the moon share story. The falling apple and the orbiting moon are two versions of the same phenomenon. The apple drops toward Earth, following a curved path through space-time. The moon moves fast enough that it never reaches the ground. It keeps falling around Earth forever. This is what orbit means. Constant falling in a curved geometry. Gravity doesn't distinguish between small and large. It follows one rule, curvature. The apple's descent and quiet choreography. The same geometry that guided the apple's fall now holds the moon's silver arc in the sky each night. The Earth doesn't pull the moon. It feels natural to say Earth pulls the moon, but that image is misleading. The moon isn't pulled. It's moving freely, gliding through curved space-time. Imagine rolling a marble around a depression on a stretched sheet. It circles not because of strings or magnets, but because the surface itself is curved. The moon follows the same principle. Its path is straight within the geometry of space-time, even though it appears curved from our perspective. What we call orbit is simply the moon obeying the shape of reality. The same geometry that bends the moon's motion also bends light, shapes tides, and governs every breath of the cosmos. In the language of Einstein, there are no poles, only paths, falling as straight motion in curved space. When you fall, you are not being pulled downward, you are moving straight ahead. Through a curved world. In Einstein's universe, free fall is the purest form of motion. If you drop from a high place, you experience weightlessness not because gravity disappears, but because you're following spacetime's natural flow. Astronauts orbiting Earth feel the same. They are constantly falling, but never hitting the ground. Their paths are straight lines in a curved geometry. So next time you imagine falling, remember, you're not descending through space. Space is curving beneath your motion. Gravity doesn't force, it guides. It's the invisible architect ensuring that everything moves exactly as geometry demands. The law of the cosmic dance. Einstein once summarized his insight with poetic precision. Matter tells space how to curve. space tells matter how to move. This is the law of the cosmic dance, an eternal feedback between what exists and the stage it inhabits. Every star, every planet, every atom contributes to the shape of spacetime, and that shape dictates their motion. The result is harmony, an elegant balance between creation and consequence. Imagine billions of celestial bodies all influencing each other, not through invisible strings, but through shared geometry. It's a dance so vast and intricate that even light cannot escape its rhythm. You are part of that dance too, your atoms participating, your mass curving the fabric, your body gliding along the silent music of existence. The architecture of spacetime. The word architecture fits gravity perfectly. It is design without a designer. Geometry without blueprint. Beauty without intention. Spacetime curves, folds, and stretches according to the presence of energy, constructing cosmic structures the way tension shapes a bridge. Where mass gathers, curvature deepens. Where space empties, it flattens. This architecture is dynamic, alive, ever-changing. Galaxies orbit within its arches. Light travels along its corridors. And time itself flows through its dimensions. To exist is to dwell within this structure. You are not standing on solid ground. You are resting within a moving cathedral of spacetime, a vast, silent architecture built from nothing but geometry and grace. The sculptor of the cosmos. If the universe were a sculpture, gravity would be the hand that shaped it. Every swirl of a galaxy, every spiral arm, every cluster and void, all are the result of gravity's patient craftsmanship. Over billions of years, it gathered atoms into stars, stars into constellations, and galaxies into grand filaments spanning the cosmos. Even the great cosmic web, that immense network of galaxies, is the product of gravitational attraction. Gravity does not rush, it takes its time. It molds the universe in slow motion, one orbit, one fall, one fusion at a time. The art it creates is everywhere we look, and within us too, in the atoms once forged by stars it sculpted. The invisible and the infinite. Gravity cannot be seen, touched, or captured, yet its reach is infinite. Every corner of the universe feels its influence. It diminishes with distance, but never truly fades. Even across millions of light years, galaxies attract one another subtly, shaping the grand structure of the cosmos. What's astonishing is that gravity arises from something as ordinary as mass, the same property that makes you feel your own weight. The same equation that governs an apple's fall also governs the motion of galaxies billions of light years apart. This unity, from the tiny to the vast, is gravity's quiet miracle, an invisible web connecting everything that has ever existed. The universe without gravity. Imagine a world without gravity, no up, no down, no orbits, no stars. Matter would never gather. The universe would remain a thin mist of lonely particles drifting forever. Planets would never form, suns would never ignite, and time itself might lose meaning. Gravity gives direction to the arrow of reality. It defines the difference between falling and flying, between chaos and creation. It allows complexity to arise, atoms join, equations that define the structure of all things. The whisper of mass. Every mass, no matter how small, whispers its presence through the fabric of spacetime. When a planet moves, the curvature ripples. When a person walks, the field adjusts, imperceptibly, but truly. These whispers combine into a cosmic harmony that defines the large-scale structure of the universe. If you could hear, the Earth moves through space, the solar system glides through the galaxy, and spacetime itself flows and ripples beneath it all. You are not separate from this motion. You are carried within it. Every second, the ground beneath you curves and shifts ever so slightly as the planet falls around the sun. You are in free fall, just cushioned by the surface that prevents you from feeling it. The sensation of weight is simply resistance to the natural motion of spacetime. You are floating on a wave of reality itself. The universe falling forever. Everything in the universe is falling, not downward, but inward, following the geometry that mass creates. Galaxies fall toward each other, stars fall toward their centers, planets fall in graceful circles, and light falls through curvature. Even expansion, the universe's outward motion, is a form of falling through time. The cosmos is an eternal dance of descent and motion, each fall giving rise to new balance. Nothing is static. Everything moves because geometry demands it. In this way, the universe is a perpetual fall, not of destruction, but of becoming. Every fall leads to form. Every curve leads to creation. Held in the curve of existence. In the end, gravity is not about weight, it's about connection. To be pulled is to belong. Every object, every person, every atom is part of a vast spacetime. And that, perhaps, is the most comforting truth of all. Isaac Newton gave gravity a formula, but not a reason. Isaac Newton looked at the falling apple and saw a mystery that stretched from the orchard to the stars. He discovered that the same force pulling the apple down also keeps the moon in orbit. A single, simple law connecting heaven and earth. His equation described the attraction between any two masses, no matter how far apart. Yet Newton couldn't explain why it worked. He gave gravity numbers, not meaning. To him, it was an invisible thread acting across empty space. Instant, precise, and unexplainable. Hypotheses non fingo, he wrote. I frame no hypothesis. He simply accepted gravity as a fact of nature. His genius was not in understanding its essence, but in capturing its behavior. It would take 2 centuries, and the imagination of Einstein, to reveal the hidden architecture behind Newton's numbers. Action at a distance. Newton's universe was. Distance was unsettling even to Newton himself. How could one body influence another without touching it? He had no answer. Space, in his view, was merely a stage, empty, absolute, unchanging. Forces passed through it like ghosts, instant and unseen. The cosmos worked perfectly, yet the mechanism was invisible. For centuries, physicists accepted this mystery as truth, trusting its results, even if they could not see its cause. But deep down, the question remained, how does gravity move through nothingness? That question would haunt physics until Einstein reimagined the stage itself, the absolute stage of Newton's world. In Newton's time, space and time were separate and fixed, an eternal grid upon which the universe unfolded. Space provided position, time provided sequence. They were the backdrop, not the actors. No event could alter them. They simply existed, unchanging. A second was a second everywhere. A meter was a meter in every corner of the cosmos. To Newton, the laws of motion played out upon this perfect, infinite scaffold. The planets danced, the stars shone, but the stage itself never bent or breathed. It was a comforting picture, simple, clean, eternal. Yet something about it felt incomplete, as if the universe were frozen in concept, not alive. For true understanding, someone had to ask a daring question. What if the stage itself can move? No influence can travel faster than light, not even gravity. The universe, once thought instantaneous, was suddenly finite in response. Information takes time to move. Causes and effects are separated by light's patience. In that realization, the old Newtonian action at a distance dissolved. Gravity could not act instantly. It had to ripple through reality. The universe was no longer mechanical, it was dynamic, elastic, alive. Light, the ultimate speed limit. Light is the universe's rule of rhythm, the limit beyond which no event can outrun. At nearly 300,000 kilometers per, gravity communicates, how information spreads, how the past becomes the present. In a way, light is the metronome of the cosmos, and all matter, all motion, dances to its beat. Gravity becomes a. They were active participants in the universe's story. When mass or energy appears, space-time bends around it. What we feel as the force of gravity is simply our motion along that curve. It's like walking straight on a globe. The path feels curved only because the surface is. Gravity is not a pull. It's a geometric inevitability. The sun doesn't send invisible strings to hold the curve the stage. Einstein's field equations capture the relationship between matter and geometry in elegant symmetry. Mass tells spacetime how to curve, and curvature tells mass how to move. The stage is no longer rigid. It flexes and breathes in response to every atom. Even light, which has no mass, feels this curvature. The result is a universe that is both structure and story. Every star, every planet, every photon plays its role, shaping and being shaped by the cosmic stage. Imagine tossing a stone into a still pond. Ripples spread outward, altering the surface. Foundation. Planets follow curved geometry. When you look at the night sky and see the planets glide along their paths, you're watching geometry in motion. The Earth orbits the Sun not because of a tug, but because spacetime curves around the Sun's mass. The Earth simply follows the straightest possible line in that curved space, what physicists call a geodesic. The same applies to every, and each body follows the natural contours. Gravity is not command, it's permission. It's the quiet instruction written into the structure of space, saying, here is the way to move. The sun bends the Earth's path. The Earth's orbit isn't drawn by force, it's carved by curvature. The sun's mass deforms space-time like a massive weight pressing into an elastic sheet. Earth circling the sun out of compulsion, but out of natural obedience to the shape of space. In this view, every orbit is an act of freedom, not restraint. Gravity doesn't confine, it defines. The curve of the sun's space-time is both the cage and the path, the reason and the rhythm of every planetary dance. Even light bends when space is warped. For Newton, light had no weight, so it couldn't be affected by gravity. But Einstein saw deeper. If gravity bends space itself, and light always travels in straight lines through space, then light must bend too, not because it's pulled, but because the path itself is curved. During a solar eclipse in 1919, astronomers confirmed this prediction. Starlight passing near the sun appeared displaced, as if the stars had shifted. It was a living fabric that could bend, twist, and ripple with energy. Gravitational lensing, the universe seeing itself. When light from a distant galaxy passes near a massive cluster, space-time bends its path, focusing it like a lens. This phenomenon, called gravitational lensing, allows us to see galaxies far behind others, sometimes duplicated, magnified, or ringed around the source of gravity. The universe becomes its own telescope, showing us its depths through the distortion of geometry. Every lensing event is the cosmos looking at itself. Light, curved by gravity. They are the grammar of existence. How geometry speaks to matter, and how matter replies. Solving them can describe an entire universe. They remind us that physics is not only about prediction, but about beauty, that the laws of nature, when seen clearly, form patterns as graceful as galaxies themselves. The deeper the mass, the deeper the well. Every massive object creates a kind of well. In spacetime, the more mass it has, the deeper and steeper the well becomes. A pebble barely dents the surface. A planet makes a wide valley. A black hole carves a pit so deep that even light cannot climb out. You can imagine existence as a landscape of invisible contours, peaks, valleys, ridges, defined not by height, but by curvature. Gravity is simply the slope of this terrain. Within its depth, Time slows near gravity's embrace. Einstein's insight extended beyond space. It reached into time itself. Near a massive object, time ticks more slowly. Clocks on mountaintops run faster than those in valleys. In the pole of a black hole, time nearly stops. This is an illusion, it's reality's own rhythm. Gravity stretches time because it warps space-time as a whole, and time is woven into that fabric. Every step deeper into a gravitational field is a step into slower time. This phenomenon, called gravitational time dilation, has been measured with exquisite precision. It means that every second you live is slightly different from someone's second elsewhere. Time is personal, curved, stretched, relative. Gravity as a distortion of duration. We often think of gravity as weight, something that presses down. But Einstein revealed a subtler truth. Gravity is the bending of duration itself. When you feel heavy, it's not just because your body is pulled. It's because your time is running slower relative to the rest of the universe. Weight is the tension between two different clocks, one deep in a gravitational field, one free of it. This perspective transforms the idea of falling. To fall freely is to let your time align with space-time's natural flow. To stand still is to resist it and to feel weight. The very sense of being. Anchored is time-resisting geometry. Every clock ticks differently. In Einstein's universe, there is no universal clock. Time is local. It flows differently for everyone, depending on motion and gravity. The clock on a satellite orbiting Earth runs faster than one on the ground, and we must correct for this daily to make GPS work. The deeper you are in a gravitational field, the slower your seconds. This truth means that simultaneity, the idea of now, is not absolute. There is no single present shared by all beings. Every place, every speed, every depth of gravity defines its own time. The universe is a tapestry of billions of ticking hearts, none of them perfectly in sync. The cosmos that bends and breathes. The old Newtonian universe was solid and still. Einstein's cosmos, by contrast, is flexible. It bends, it ripples, it breathes. Space expands, contracts, and vibrates with energy. Massive events send waves through space-time, like the surface of a pond disturbed by falling stars. The universe is not static. It is alive with motion and elasticity. This shift changed everything. Reality became a process, not a place. What we call space is more like an ocean than a grid, vast, dynamic, and filled with tides of curvature. To live within it is to float forever on invisible waves of time. Surroundings. Objects follow the simplest possible paths through curved space-time, and that motion is what we perceive as attraction. This revelation was both mathematical and philosophical. Every fall, every orbit, every second is a line drawn upon that endless surface. The universe becomes a fabric, not a battlefield. Before Einstein, physics was a story of collisions and pushes, of forces battling across the void. After Einstein, the picture softened. The universe was no longer mechanical. It was organic, interconnected, fluid. There were no external pulls or invisible. Instead of struggle, there was flow. Instead of battle, there was balance. In Einstein's hands, the cosmos became not a machine, but a melody, one of geometry, light, and time. Time and space. Inseparable. Einstein's greatest gift to human understanding was the realization that time and space are not two things, but one. They are woven together into a single, four-dimensional fabric. The separation we perceive, between up and forward, between seconds and meters, is an illusion born of limited perspective. In truth, we are travelers within one continuous flow, shaped by gravity and illuminated by light. To exist, then, is to move through space-time's embrace, forever, gracefully, and inseparably. Imagine laying a grid across the cosmos. Imagine spreading a perfect grid, an endless lattice of invisible lines, across the universe. Every intersection marks a point in space-time, each distance measured in meters and seconds. Now imagine placing a star on that grid. The neat squares around it begin to bend, drawn inward by its mass. The grid is no longer flat. It becomes curved, like fabric under weight. This simple mental image is how physicists visualize gravity. Space itself changes shape around matter. If we could somehow see the grid in reality, it would shimmer and warp gently around every planet, every star, even around you. The universe isn't drawn on this grid. The grid is the universe, constantly reshaping itself to hold everything that exists. Where there is mass, the grid bends. Mass and energy are like fingerprints pressed into the more mass something has, the stronger the curvature it creates, and the more influence it has over its surroundings. The universe responds to every bit of mass with quiet precision. Everything moves, and so the curvature moves with it. When a planet orbits its star, its motion subtly ripples through the surrounding spacetime. As galaxies drift and collide, the shape of the cosmic grid flows and changes. It's a dance of geometry. Matter moves, and the geometry flexes in response. Even light participates, following the changing curves as if sliding down invisible hills. This constant adjustment happens everywhere, every moment. The geometry of reality is alive, dynamic, responsive, and endlessly fluid. In a sense, gravity is not a single field but an ongoing choreography between matter and motion. Every second, the universe redraws itself, keeping perfect balance. Space and time stretch and compress. When space-time curves, it doesn't just bend, it stretches and compresses both space and time themselves. In deep gravity wells, distances appear longer and seconds pass slower. Near massive stars, a meter can feel stretched and a minute can last. Energy flow through it. When you walk across the room, your motion slightly alters the space around you. When you sleep, your mass rests gently in the grid, pressing time and distance into subtle new. Distant stars, the orbits of planets, the timing of pulsars, all reveal the shape of spacetime. In 1919, astronomers photographed starlight during an eclipse and found it displaced by the sun's gravity. That single observation proved Einstein's theory. Space was curved, and light followed its bends. Today, we measure this curvature with extraordinary precision, using satellites, lasers, and atomic clocks. The results are always the same. The universe is not flat. It's subtly curved everywhere, molded by the quiet presence of mass and energy. What was once invisible is now traced by. To an observer on Earth, the star seems to have shifted position in the sky. During the solar eclipse of 1919, Sir Arthur Eddington measured this shift, a tiny angle, yet enormous in meaning. It was the first proof that Einstein's theory of general relativity was true. The sun didn't pull on the starlight. It bent the space the light moved through. The discovery was so profound that it changed how humanity saw reality itself. Light no longer traveled through emptiness. It moved through a living, flexible fabric that responded to the presence of stars. The cosmos had become geometric. Gravity lenses the universe like glass bends light. Massive objects, like galaxy clusters, can bend light from objects far behind them, magnifying and distorting the view. This is gravitational lensing, the universe acting as its own telescope. Sometimes the light forms rings, arcs, or mirrored images of the same galaxy. Through these lenses, we can see galaxies, billions of light years away, glimpsing the early universe. What's astonishing is that the lens is made not of glass or crystal, but of gravity itself, space-time so deeply curved that it behaves. Worlds, but the structure of reality itself. Gravity wells, folds in the metric of reality. We often speak of gravity wells, as if stars and planets sit in bowls of space. In truth, these wells are folds in the metric, the mathematical fabric that defines distances and durations. The deeper the well, the stronger the gravity, and the slower the flow of time inside it. A planet's surface is a gentle slope. A neutron star's is a steep cliff. A black hole's well is so deep that the bottom never ends. When you move within these folds, your very sense of direction and the black hole, where the curve becomes infinite. A black hole is where curvature reaches its limit. The grid of spacetime folds so sharply that all paths lead inward. The escape velocity exceeds the itself. Inside lies the singularity, the point where known physics collapses. At the event horizon, time slows to stillness. For an outside observer, it freezes completely. To fall into a black hole is to enter geometry so extreme that direction, distance, and duration lose meaning. It is the purest expression of gravity's power, and perhaps the universe's greatest secret, the singularity. Beyond time, at the center of a black hole, the equations of general relativity predict an infinite curvature, a singularity. It's not just a point of density, but a breakdown of geometry itself. Time and space cease to behave as we know them. The past, present, and future converge into a timeless state. Some physicists believe singularities don't truly exist, that quantum effects smooth them, twist like silk, and ripple like water. When massive objects move, they disturb spacetime, sending out waves that travel at the speed of light. When the universe expands, the very distances between frame dragging. Every form of motion leaves its mark upon the fabric. The cosmos is not a frozen sculpture. It's a living tapestry, woven and rewoven in every moment. Gravitational waves. Ripples in reality. When two massive bodies collide, black holes, neutron stars, collapsing cores, they send ripples through spacetime called gravitational waves. These waves travel across the universe, stretching and squeezing space as they pass. In 2015, the LIGO Observatory detected one for the first time, confirming Einstein's century-old prediction. The signal was faint, smaller than a fraction of a proton, yet powerful enough to reveal the merger of two black holes over 1 billion light-years away. Gravitational waves are the whispers of the universe, soundless, invisible but real. They remind us that even space can tremble, that the fabric of reality can sing. The universe is elastic, not rigid. Nothing in the cosmos is truly still. Space stretches under pressure and recoils when released. The expansion of the universe itself proves this elasticity. Galaxies drift apart not because they travel through space, but because the space between them grows. This expansion can accelerate, slow, or oscillate depending on energy and matter. Like a living membrane, the universe responds to what it contains. This elasticity is what allows waves to propagate, black holes to form, and time to flow smoothly despite curvature. It is the softness of existence, a property that makes motion, causality, and even thought possible. The universe doesn't resist change, it absorbs it gracefully. Tremors from a supernova. When a star dies in a supernova, the explosion is so immense that it sends shock waves not only through matter, but through spacetime itself. The collapse and rebound of its core ripple outward, creating tiny distortions that can travel across galaxies. These gravitational tremors are unimaginably weak by the time they reach us. But they carry information, a record of the star's final heartbeat. Each detected wave is a message from a distant death, written in the fabric of the cosmos. To hear it is to witness the memory of light extinguished and reborn as geometry. Even in destruction, the universe communicates through curvature. The cosmic web suspended in geometry. On the largest scales, the universe forms a vast Network, the cosmic web of galaxies and clusters connected by filaments of dark matter. These filaments trace the underlying geometry of spacetime itself. Where curvature is strong, matter. Spider's web, glowing faintly with galaxies. The silk threads are invisible spacetime, and the luminous beads are the galaxies it holds. The pattern is not random. It is geometry given form. Mass tells geometry how to dance. In every corner of the universe, matter and geometry perform an endless duet. A passing comet bends the local curvature. A distant quasar twists light into arcs. Space-time responds instantly, not with noise, but with motion, a soft, perpetual dance of presence and form. This is the essence of Einstein's vision. Gravity is not force, but choreography. The steps are subtle, the rhythm silent, the balance perfect. To exist is to participate in this dance. You are both dancer and stage. Your mass shapes geometry, and geometry guides your motion. The dance never ends. It only evolves, endlessly graceful. Every photon step is shaped by curvature. Light travels straight, yet its straightness depends on geometry. Every photon that leaves a star follows the natural path carved by space-time, the shortest route through a curved landscape. When it passes near massive objects, its direction changes, not because of pull, but because the terrain shifts beneath it. Every gleam of starlight, every sunrise, every glimmer in the night sky is geometry guiding light. Even the light entering your eyes tonight has been bent and delayed by the universe's curves. When you gaze upward, you are not just seeing stars. You are seeing the shape of reality, traced in luminous threads. Even nothingness has form. We often call space empty. But physics tells another story. Even where there is no matter, space-time has structure, a geometry defined by its potential to bend. Quantum fields hum quietly in the vacuum, filling every corner with invisible energy. This background energy contributes to curvature, shaping how galaxies move and how the universe expands. Nothingness, it seems, is full of something, a quiet tension, a readiness to become. The void is not blank. It is the canvas upon which existence paints its patterns. Even silence has architecture, the texture of space. Space is not a void, but a medium, smooth. To us, yet infinitely detailed. It has texture, like silk viewed under a microscope, rippling with invisible waves of energy. This structure carries tension and flow, storing the history of all that has passed through it. The trails of planets, the pulses of light, the tremors of ancient collisions, all leave faint marks on its weave. If we could see spacetime directly, it would appear alive. A shimmering ocean of geometry, breathing with every heartbeat of the cosmos. The truth is simple and profound. Space itself is the substance of reality. You are made of space, living in space, moving through its folds. You are not apart from space. You are made of it. The atoms in your body are condensed ripples of spacetime's energy, vibrating in harmony with the universe's geometry. Every cell, every breath, every heartbeat is a localized curvature of reality. When you move, spacetime moves with you. When you rest, it settles gently around you. You are part of the same fabric, but also time itself. Near a massive object, where space-time curves deeply, seconds stretch longer. Far from that mass, where the curve flattens, seconds run faster. This means that time is not of the universe. When you stand on Earth, your seconds are a little slower than those of the stars above you. Gravity does not only shape motion, it shapes duration, the quiet heartbeat of existence itself. The closer you are to mass, the slower your seconds. Imagine holding two identical clocks, one on a mountain, one deep in a mine. To your eyes, they seem to tick together, but under, gently slowing it near its heart. The closer you are to matter, the more you dwell within its gravity, and the slower your life's rhythm becomes. On mountains, clocks run faster. High above the ground, away from the Earth's center, time flows a little quicker. The difference is tiny, only billionths of a second per day, yet it exists. Astronauts, pilots, even mountain climbers live. Different universe. If you lived your whole life atop a mountain, you would age a fraction of a second more than someone living at the shore. Time, it seems, is a landscape, and altitude is one of. Slightly stronger than on the ridge above. Space-time dips into a small valley, and time slows just a little more. Each second becomes longer, stretched by the presence of mass. You wouldn't notice. Of course, the difference is too small to feel. But over millennia, it adds up, a reminder that even the most ordinary landscapes are also landscapes of time. Gravity doesn't only pull bodies downward, it pulls moments, too, holding them gently near matter's embrace. Time itself falls in a gravitational field. When an object falls, it's not just matter that moves, time itself bends. Space, but through time curved by gravity. Every orbit, every descent, every heartbeat is a soft surrender to that flow. GPS satellites must correct for this difference daily. Without Einstein, your phone's navigation would be wrong by kilometers each day. GPS satellites orbit high above Earth, where gravity is weaker and time runs faster. On the ground, clocks run slower. The satellites must constantly adjust their timing to stay in sync with receivers on Earth. Engineers use Einstein's equations to correct for both special and general relativity, motion and gravity. Einstein's curved time keeps the modern world aligned. Without Einstein's equations, navigation would drift. Every GPS receiver you use, in your car, phone, or airplane, relies on clocks that run at the right speed in curved spacetime. If we ignored relativity, GPS errors would grow by about 10 kilometers every day. The system would be useless. Instead, every satellite's onboard clock is adjusted before launch, calibrated to tick slower so that it matches Earth time once in orbit. This is relativity in action, not theory, but practice. Every journey, every delivery, every rescue mission depends on understanding how gravity bends time. Without Einstein, we would be lost, not in space, but in seconds. Time and gravity, two faces of the same rhythm. Time and gravity are not separate. They are two expressions of one cosmic rhythm. When mass appears, gravity curves space-time, and that curvature is what we experience as time's distortion. Gravity slows time. Time, in turn, defines gravity's direction. The pull you feel downward is the shape of time flowing toward the planet's center. You are not being pulled, you are following the natural slope of temporal flow. Every object in the universe is falling through time at the same fundamental pace, only slowed or stretched by mass along the way. To feel weight is to feel time bending beneath you. Every orbit is a distortion of time. A planet orbiting a star is not just moving through space. It's moving through a region of slower time. The closer the orbit, the slower the seconds. Every revolution traces not only a circle in space, but also a spiral in time. The result is a rhythm unique to each world. On Mercury, time is slower than on Earth. Near Jupiter, slower still. Even our moon, circling us nightly, lives in a slightly different timeline. The universe is a grand symphony of clocks, each ticking at its own tempo, synchronized only through the language of relativity. Every orbit is a song written in curved time. The universe ticks unevenly, yet beautifully. There is no universal tick marking the heartbeat of the cosmos. Every place has its own measure of time, slower here, faster there. The universe is a choir of uneven rhythms, and yet it stays in harmony. The equations of relativity weave these differences together into a single, coherent flow. Time dilates where gravity reigns, stretches where space expands, and yet it all fits, like music in complex time signatures. Your seconds are not the same as those on Mars or near a black hole, but the melody continues unbroken. The universe is a vast symphony of asymmetry, and its music is beautiful. Near black holes, time nearly halts. As you approach, strange, you move naturally, unaware that outside time has nearly stopped. This is gravity at its extreme, the bending of duration until it folds upon itself. A black hole is not just a place where light cannot escape, it's where time itself becomes trapped. Near the event horizon, seconds stretch into eternity. The deeper you go, the slower you exist, until the difference between motion and stillness disappears completely. A second for one can be a century for another. In the realm of strong gravity, relativity creates staggering differences. A single second for one observer near a massive object could equal decades or even centuries for another far away. This is not imagination, it's measurable physics. If you hovered near a black hole for a short while and returned, you might find that generations had passed elsewhere. This idea, explored in Einstein's equations and even in science fiction, reveals how deeply time is tied to position. There is no single now. Light signals traveling upward slow down in gravitational fields. The equations of general relativity predict these effects with astonishing accuracy, and nature agrees. The universe doesn't play. Eternity. The arrow of time bends with the curvature of space. Time has direction. It moves from past to future, from memory to possibility. But that arrow bends with space itself. In strong gravity, where space-time curves steeply, time's arrow tilts, pointing toward the source of mass. The flow of events literally angles inward. This connection between geometry and direction defines the structure of reality. The arrow of time is written in the geometry of the universe. Entropy flows differently where gravity reigns. Entropy, the natural drift from order to disorder, defines the direction of time. Pile up, frozen in the curvature. Paradoxically, this frozen state still increases the total entropy of the universe, showing that even where time nearly stops, the arrow continues to point forward. Gravity doesn't erase the flow of time, it refracts it, like light through a lens. Even near eternity, change never ceases. Time may be born from gravitational complexity. Some physicists believe time itself emerges from gravity. The more complex the geometry of spacetime becomes, with its folds, twists, and waves, the more meaning before and after acquire. In a perfectly uniform universe, time might have no direction at all. It is the unevenness, the curvature, that creates sequence. Gravity sculpts not only space, but causality. Perhaps time began when matter first clumped together. Black holes preserve information through time's distortion. Stephen Hawking once proposed that black holes might erase information, a troubling idea in physics. But later discoveries suggested the opposite. Information is preserved, encoded on the surface of the event horizon. As time slows there, it doesn't destroy data, it stretches it endlessly, storing it on the edge of space. In a sense, black holes are cosmic archives, holding the imprints of everything that falls within. Gravity doesn't erase memory, it transforms it into geometry. The surface area of a black hole even measures its entropy, a perfect bridge between time, gravity, and information. To fall into gravity is to fall through time. When you fall, you are not merely moving through space, you are moving through the slope of time itself. The sensation of weight, of descent, is really your body aligning with the natural direction of temporal flow. To float, to orbit, to fall, all are ways of tracing time's curved path. The Earth, the Moon, even light itself, are constantly falling through the river of space-time. The entire cosmos is descending, not into darkness, but into the future. Gravity is the shape of that descent, the guide that turns eternity into motion. The fabric of space-time weaves every memory, everything that has ever happened, every light pulse, every heartbeat, every orbit is woven into space-time. The past is not gone. It is folded behind us in the geometry of the universe. Every movement leaves a faint mark on the cosmic fabric, an indentation of energy. And duration. In Einstein's picture, the universe is a four-dimensional tapestry where all events exist together, past, present, and future forming one vast structure. What we experience as now is simply the slice we're moving through. Memory is geometry, and every life is a pattern in spacetime's weave. All moments coexist in the curve. Perhaps the most beautiful idea of relativity is that every moment, from the birth of stars to the quiet of this second, still exists somewhere in the vast continuum. Time does not vanish. It merely changes location within the curve. The universe holds all events simultaneously, like pages in an infinite book. What we call now is only the line we are reading. Somewhere, your first breath still expands into the air. Somewhere, a star still ignites. Somewhere, the future is already unfolding. Gravity connects them all, bending the timeline into a single, eternal shape, the living fabric of reality. In 1916, Einstein predicted waves in spacetime. Just a year after completing his general theory of relativity, Einstein glimpsed something extraordinary. If mass could bend spacetime, then moving masses would stretch and squeeze space as they traveled, carrying the memory of violent cosmic events. Einstein wasn't sure they could ever be detected. They were too small, too subtle. For him, they were a poetic consequence of his equations, the universe's way of whispering its motion into infinity. Yet that whisper would one day be heard. For a century, they remained silent. For nearly last forever. In 2015, LIGO heard them at last. On September 14, 2015, at two observatories on opposite sides of the United States, laser beams trembled ever so slightly, by less than a thousandth of an atomic nucleus. The pattern matched Einstein's prediction perfectly. Two black holes had collided over 1 billion light-years away, sending waves through space-time that reached Earth after. Humanity didn't just see the universe. We heard it, in the language of gravity itself. A century-old prophecy had come true. Two black holes collided, and the universe rang. The event LIGO recorded to 3 suns was converted entirely into gravitational energy, radiating outward as ripples in spacetime. The burst lasted only a fraction of a second, yet released more power than all the stars in the observable universe combined. It was as if reality itself had struck a chord, vibrating through the void. The universe had made sound, not of air, but of geometry. The signal lasted only milliseconds. The entire event that confirmed Einstein's theory lasted less than 1/5 of a second. On LIGO's instruments, it appeared as a gentle chirp, a brief, rising tone. The frequency increased as the black holes drew closer, spiraling faster until the instant of collision. That chirp carried the mass, spin, and distance of the event encoded in its pattern. Such a fleeting whisper revealed everything. The end of two black holes, the birth of a new one, the bending of spacetime across 1 billion years. The signal was short, but its echo changed. Physics forever. A century of theory confirmed. When scientists analyzed the data, the match with Einstein's 1916 equations was perfect. Every detail, the amplitude, the frequency. Once speculative ripples were real. The universe was not a silent void, but a resonant ocean of waves, the geometry of existence vibrating with ancient events. what had once been only numbers on, then returns everything to normal. You never feel it. The distortion is too faint. Yet it is there, the heartbeat of the universe, pulsing through all matter. These are not ripples in a medium but ripples of the medium. The universe does not vibrate within something else. It vibrates within itself. They carry no light, no sound, only curvature. Gravitational waves are utterly silent. They carry no light, no electromagnetic energy, no sound that air could transmit. They are pure geometry in motion, space-time flexing and relaxing as it propagates. Each wave carries information about the event that made it, its size, its energy, its distance. Where telescopes see light, gravitational detectors feel shape. The universe, then, speaks in two languages, brightness and contracts, even through you. Right now, as you read these words, gravitational waves are passing through your body. They stretch the distance between your eyes and the screen, compress your atoms by an infinitesimal fraction, then return them exactly as they were. The same waves pass through the Earth, the Moon, every planet, without resistance. They leave no trace, only a rhythm too delicate to perceive. Yet these tiny distortions link you to the farthest events in the cosmos, the death of stars, the merging of black holes, the collisions of galaxies. You are not just watching the universe, you are part of its pulse. Billions of waves pass through Earth each second. Every moment, countless gravitational waves from ancient events sweep through our planet. Most are far too weak for our instruments to detect, yet they are everywhere. Ghostly ripples from collapsing stars, orbiting pulsars, cosmic strings. The Earth is immersed in this invisible ocean. We float within it, unaware, like fish in a silent sea. Our detectors, like delicate nets, catch only the largest waves. But even the smallest are there, whispering of motions across galaxies. The universe is never. When a wave passes, the distance between 2 points changes by less than 1 part in a trillion trillion. Your body doesn't notice, your senses can't perceive it, yet the shift is real. To detect such minute motion, scientists use lasers and mirrors suspended in vacuum, shielded from even the vibrations of molecules. It is a kind of cosmic meditation, the stillness required to hear. LIGO, we could only see the universe. Light from stars, radio from pulsars, X-rays from galaxies. Now, we can feel it move. Gravitational waves prove that massive objects do not exist in silence. When we detect them, we are not hearing sound. We are sensing the pulse of existence itself. They are proof that the universe is not a painting, but a song still being sung. The universe hums in space-time frequencies. If you could translate gravitational waves into sound, the universe would hum like a vast orchestra. Deep bass notes from merging black holes, higher tones from neutron stars, faint tremolos from pulsars. Each frequency corresponds to a different kind of motion, a different cosmic event. Together, they form the music of space-time, an unending resonance that fills the void. Though we cannot hear it with our ears, the instruments of science allow us to sense this hidden harmony. The cosmos does not merely exist. It vibrates, softly, beautifully, forever. Neutron stars create deeper tones. When two neutron stars spiral together, their collision produces a distinct kind of gravitational wave, slower, deeper, longer than that of black holes. These stars, made of compressed atomic nuclei, orbit at incredible speed before merging in a final burst of light and curvature. Their death creates gold, platinum, and other heavy elements that later form planets, rings, and jewelry. Every piece of metal you wear was once part of such an event. The gravitational waves from those collisions carry the memory of creation itself, a low, steady note in the cosmic symphony, resonating across billions of years. Collapsing supernovae send brief pulses of existence. When a massive star dies, it collapses inward under its own gravity, then explodes outward in a supernova. The collapse and rebound send a tremor through space-time, a brief, chaotic pulse of gravitational energy. These waves are messier than the clean spirals of merging black holes, but they tell us about the heart of stellar death, how matter folds and rebounds, how the cores of stars become neutron remnants or black holes. Each pulse is a signature of transformation, the last breath of a star echoing through space-time. Even in death, the universe leaves ripples that never fade. Each wave is a message from distant gravity. Every gravitational wave carries a story. Its frequency tells of mass. Its amplitude speaks of distance. Its shape reveals the kind of motion that birthed it. When we detect one, we are reading a message written in the oldest, most universal language, geometry. Unlike light, these messages are never blocked or scattered. They pass through stars, dust, and darkness without loss. They are pure, direct memories of what truly happened. Each wave is a courier from distant gravity, arriving after billions of years to whisper, "I was there." Gravitational astronomy has begun. The detection of gravitational waves marks the birth of a new science, gravitational astronomy. For the first time, we can observe the universe without light. Telescopes show us what shines. Gravitational detectors show us what moves. Together, they allow us to understand the cosmos more completely than ever before. With each new signal, we refine our map of existence, not just where stars are, but how they dance. We are no longer limited to sight. We have learned to listen. The universe has begun to speak in a new way, and we are learning its rhythm. Listening to the universe bend. When LIGO Virgo. To hear it is to experience something no human once thought possible, the sound of gravity itself. It's not music made by instruments, but by motion, not composed by humans, but by the universe. Each detection is a new note in the symphony of being, each collision a measure in the score of time. Every wave tells a story of mass becoming motion. At the heart of every gravitational wave lies a. Across the cosmos, black holes merge, stars die, galaxies collide, and each act becomes a ripple in eternity. These waves are the autobiography of the universe, written not in light or color, but in curvature. Every pulse that reaches us is a reminder that nothing ever truly stands still, not even the fabric of reality. The cosmos breathes in gravitational rhythm. In the end, the universe is not silent. It breathes. Each expansion, each collision, each rotation adds a pulse to its eternal rhythm. Gravity, light, time, all move in unison, rising and falling like the tide. You are part of that rhythm too. Every breath you take mirrors the slow exhalation of galaxies. Every heartbeat echoes the quiet oscillation of space-time. The cosmos hums softly around you. And within you, the universe breathes, and through gravity's waves, it reminds you that everything, everywhere, is part of one endless vibration. A black hole is gravity at its purest. A black hole is not a thing, but an extreme condition, gravity stripped of everything else. It is what happens when matter collapses beyond the point of resistance, when even atoms surrender and spacetime itself curves without end. It is gravity made absolute, pure curvature detached from form. There are no surfaces, no structures, no solid edges, only geometry folding into itself. Inside, the usual rules of reality dissolve. There is no up, no down, no escape. To stand before a black hole is to stand before the distilled essence of the universe's most fundamental force, the place where gravity stops describing the world and becomes it. In this darkness, the universe shows us the depth of its own design. Nothing escapes its geometry, not even light. At the heart of every black hole lies a region where gravity curves spacetime so completely that all possible paths turn inward. Not even light, the fastest thing in existence, can climb out. Once it crosses the boundary, known as the event horizon, it is lost from the external world forever. It doesn't vanish instantly. It simply follows the geometry inside, where every route leads deeper, to the outside universe. That light fades and stretches endlessly, red shifting into invisibility. What we see as darkness is not absence, but imprisonment, light still traveling, forever unable to return. In this sense, a black hole is not a void but a trap made of time. At the event horizon, space folds back on itself. The event horizon is the boundary where space-time curves so sharply that the concept of outward loses meaning. For an outside observer, objects approaching it seem to slow down, frozen in time. Yet from the falling object's own view, it crosses the horizon effortlessly. Inside, directions invert. What once pointed outward now points inward. It's as if the entire structure of reality folds, creating a region where geometry no longer agrees with intuition. The event horizon. The outside view. If you watched a spacecraft fall toward a black hole, you'd never see it cross the horizon. Its image would slow, dim, and freeze, suspended at the edge forever. From your perspective, time stops there. But for the traveler, time flows normally. They fall through without pause, unaware that to the rest of the universe, they've become eternal. This strange duality is not illusion. It's how space-time actually behaves. Time itself stretches infinitely near the horizon, like taffy pulled thin. The deeper the gravity, the slower the seconds. Not only a well of space, but a well of time. A frozen moment in the endless present. Inside, all paths lead inward. Once inside the horizon, motion is no longer a choice. Every possible direction, forward, backward, even sideways, points toward the singularity. The center of the black hole is not a place you can avoid. It's the future itself. Falling into a black hole is not like falling into a pit. It's being carried forward in time, where time ends. There is no path out because there is no direction left that leads away. In that sense, a black hole doesn't just trap objects. It traps their futures. Everything that crosses its boundary continues inexorably toward the same fate. The ultimate convergence of matter, motion, and time. Mass compresses into infinite density, or so we think. According to classical general relativity, all the mass that falls into a black hole collapses into a single point of infinite density, the singularity. But infinities in physics often signal space-time loops, foams, or dissolves into quantum chaos. Infinity, perhaps, is not a physical reality but a mathematical warning that our tools have reached their breaking point. The singularity, then, is less a place and more a question, waiting for an answer that unites gravity and quantum theory. Quantum mechanics whispers another story. Quantum mechanics, the language of the very small. Constant fluctuations he called quantum foam. If this is true, then the point at a black hole's center might dissolve into a froth of spacetime itself, where geometry is no longer continuous but the ultimate density of matter may be not infinite compression, but infinite motion, spacetime boiling with possibility. Information may never be truly lost. For decades, scientists believed that anything falling into a black hole was lost forever, its information erased from the universe. But quantum theory forbids true loss. Every interaction, every particle, must leave a trace. Its surface, like ink stretched thin on a balloon, the details of everything that falls and may be encoded in faint quantum ripples at the horizon. The universe, it seems, never truly forgets. Hawking radiation slowly erases black holes. In the 1970s, Stephen Hawking made a stunning discovery. black holes aren't entirely black. Quantum fluctuations near the event horizon create pairs of particles. One falls in, the other escapes as radiation. Over eons, this Hawking radiation causes black holes to lose mass and eventually evaporate. It's a slow, ghostly process, a whisper of. With the persistence of time, nothing is eternal, not even a black hole. Where gravity, quantum theory, and entropy meet, black holes are crossroads, the meeting point of gravity, quantum mechanics. Except in geometric form. In them, the universe reveals its unity. Motion becomes heat, information becomes area, gravity becomes entropy. They are the laboratories of ultimate truth, where all the great theories converge. To study a black hole is to stand at the edge of all physics, where the universe hints at the next chapter of its own story. Black holes are not holes, You can think of them as one-way membranes, marking the limits of observation. Outside, the laws of physics work as usual. Inside, the geometry changes so profoundly that words like place and time lose meaning. What we call a hole is really a veil, the surface where knowledge ends. Beyond it lies not nothingness, but a deeper form of the same reality, folded out of view. Determines the area of the event horizon. That area, in turn, represents entropy, the measure of information hidden within. Temperature arises from quantum effects near that surface. These relationships form a perfect triangle: geometry, thermodynamics, and information, each defining the other. It's as if the universe designed black holes as reminders that knowledge, energy, and shape are one. Reality, at its core, is not divided. It is woven from the same thread of meaning. The surface encodes everything that fell inside. Everything that crosses the event horizon leaves an imprint on the surface, not in matter, but in quantum vibrations. Like ripples on a pond that record a stone's fall, the horizon preserves faint traces of what has vanished beneath. The mass, spin, and charge of a black hole summarize this information, but deeper layers may hold the full story. Physicists describe this as holographic encoding, a cosmic bookkeeping system that keeps the universe honest. The information may never return, but it is never truly gone. The horizon itself remembers. Entropy equals the area of the horizon. In 1972, physicist Jacob Bekenstein proposed a radical idea. The entropy of a black hole, its measure of information, is proportional not to its volume, but to the area of its event horizon. Each tiny patch of surface, about the size of a Planck square, holds one bit of information. This discovery reshaped our understanding of the universe. It suggests that reality's deepest secrets are not stored inside things, but on their holes. A profound principle emerges. Perhaps everything in the universe stores its information on surfaces. This idea, called the holographic principle, proposes that the entire cosmos can be described by data inscribed on a two-dimensional boundary, like a hologram projecting a 3D world. Reality may not be volumetric, but encoded. Our perception of depth and space could be an emergent property, a grand illusion born from information woven across a cosmic screen. Every boundary becomes a page, every horizon a story written in light and curvature. Holographic gravity may describe all spacetime. If the holographic principle is true, then gravity itself, the curvature of spacetime, might emerge from the way information is organized on these boundaries. Spacetime could be a kind of projection, its geometry arising from patterns of entanglement between quantum bits on a lower dimensional surface. In this view, the universe is not built from particles, but from relationships, invisible threads of information forming the texture of space and time. Gravity, then, is not fundamental, but emergent, the visible echo of an invisible code that underlies all things. We might live in a projected geometry. Imagine that everything you see, stars, galaxies, even your own body, is part of a grand projection. Like a hologram, our three-dimensional world may arise from two-dimensional information stored at the edge of the universe. The illusion is perfect. Depth, motion, and gravity all appear real because of how the projection unfolds. To live in such a world doesn't make it less meaningful. It makes it more mysterious. We are the shadows of something deeper, shapes cast by the information woven through spacetime. May simply be perspective. The universe might be like a cosmic movie projected onto the screen of spacetime, vivid, detailed, and fully consistent, yet ultimately encoded elsewhere. Is holographic. Gravity may be the bridge that links illusion and reality. It is the phenomenon that converts information on surfaces into the feeling of volume, the pull that makes projection tangible. Gravity gives depth to the hologram, weight to the dream. It transforms pure information into experience. Without it, everything would be flat, literally and figuratively. Through gravity, the cosmos becomes dimensional, interactive, alive. Whether or not we are shadows on a screen, gravity ensures that our world feels real, a geometry so perfect that even illusion becomes truth. Gravity built everything we see. Every mountain, every planet, every star owes its existence to gravity. After the Big Bang, the universe began as a smooth, expanding mist, uniform, silent, featureless. But even in that near-perfect stillness, tiny differences in density appeared, and gravity noticed them. It pulled matter together, patiently amplifying the faintest variations until clouds became clusters, clusters became stars, and stars became galaxies. Gravity sculpted the very texture of reality, deciding where light would shine and where darkness would linger. Every atom in your body, forged in stars that gravity once ignited, carries the mark of this ancient builder. The universe, in all its complexity, is the result of one simple law applied over endless time, that all things attract. From dust to stars, stars to galaxies. In the beginning, there was only gas and dust, hydrogen and helium floating in the vastness. Gravity gathered these. There remained scattered, enriching space with carbon, oxygen, iron, the ingredients for planets and life. Gravity gathered those remnants again, forming new stars surrounded by worlds. Sculptor of the cosmic web. Across the deepest reaches of space lies a vast structure called the cosmic web, an immense network of filaments connecting galaxies across billions of light years. It looks like a neural network or the delicate strands of frost on glass. Gravity shaped it all. Over cosmic time, matter flowed along invisible gravitational currents, gathering into knots and stretching into threads. Dark matter, unseen but dominant, provided the framework, and ordinary matter followed. The result is breathtaking. Galaxies aligned along vast filaments. That shapes the motion of everything, from clusters of galaxies to the spin of stars. We are surrounded by its presence, living in the hollows of its invisible design. Galaxies dancing around it. Gravitational field like dancers moving around a silent partner. The space between them hums with invisible tension, an equilibrium of motion and pull. Astronomers can measure this by watching. Hydrogen and helium would float endlessly apart, never colliding, never compressing into stars. There would be no light, no heat, no chemistry, no life. The laws of physics might still exist, but there would be no story for them to tell. Gravity gives meaning to matter. It brings particles together, lets them interact, fuse, ignite. It transforms chaos into form, potential into presence. Without gravity, existence would remain scattered, a sentence without syntax, a universe without structure, a symphony without sound. The Milky Way, a gravitational masterpiece. Our galaxy. The Milky Way is a grand spiral of 400 billion stars, all orbiting a common center. Its elegant arms, swirling in cosmic slow motion, are held together by gravity's unbroken balance. Every star follows its own curved path, yet the collective motion forms a perfect pattern, a galaxy breathing in rotation. Dark matter forms its unseen halo, keeping the arms from flying apart. In the galactic core lies Sagittarius A*, a supermassive black hole whose gravity anchors the whole design. The Milky Way is a cathedral built of falling, an enduring sculpture of motion, harmony. Delicate harmony that defines every orbit. Planets, moons, and stars all exist in this state of graceful tension. The balance of pull and spin is what allows stability in chaos. Even galaxies, rotating like cosmic wheels, maintain their shapes because of this equilibrium. It's a universal dance, motion curved by gravity, gravity guided by motion. The result is elegance, chaos tamed by geometry, the choreographer of cosmic harmony. Gravity is the ultimate choreographer. It sets the tempo of planets, the rhythm of moons, the spiral of galaxies. Every orbit, every rotation, every tidal pulse is part of its choreography. It does not command with force, but with inevitability, a geometry that leaves no wrong step. Even collisions follow its design, merging worlds into new patterns. The universe moves not in random chaos, but in rhythm. Gravity writes the music, and matter dances to it. In its silent guidance lies the beauty of everything that moves. From the smallest dust grain to the largest cluster of galaxies. Even chaos follows order. When galaxies collide or stars explode, it may look chaotic, but the underlying order never vanishes. Every fragment still obeys gravity's equations. Even the debris from destruction follows elegant arcs through space, recombining into new forms. Gravity transforms disorder into design. Over billions of years, it turns explosions into symmetry, scattering into structure. It's the quiet assurance that beneath apparent chaos, harmony endures. The universe may erupt, collapse, and collide, but gravity always gathers what's left and begins again. Creation, destruction, and rebirth, all are chapters in gravity's unending architecture. Planets in musical resonance. In many solar systems, planets orbit their stars in resonant ratios, like musical notes harmonizing in time. One planet completes 2 orbits while another completes 3, or 5, or 8. These resonances are not coincidence. They are the result of gravity's subtle tuning. Over time, gravitational tugs synchronize the motion of worlds, locking them into harmonic rhythms. Played on the instruments of stars and planets, moons and tidal rhythm. Moons, too, dance to gravity's tune. As they orbit their planets, their gravity pulls on oceans and crusts, creating tides and slow shifts in rotation. Over time, this interplay locks their motions into perfect synchronization, one face always turned toward the other. The moon shows Earth only one side because of this. Gravitational rhythm. The same process shapes the dance between Jupiter and its moons, between Saturn and its rings. Tides are not just movements of water. They are conversations between worlds, whispered across the silence of space. Oceans rising to the moon. Every tide that sweeps across Earth's shores is an echo of the moon's gentle pull. The oceans swell toward the moon, and a smaller bulge forms on the opposite side, as Earth's rotation carries water through the gravitational gradient. This constant movement redistributes energy, slowing Earth's spin slightly each century and pushing the moon farther away. The tides are ancient and precise, the heartbeat of Earth in spacetime. With every wave that falls upon the sand, gravity speaks softly of our planets. Connection to the heavens. The rhythm of life in gravity's embrace. Our bodies, our breath, our cycles, all are tuned to gravitational rhythm. The tides shape ecosystems, guiding the migrations of fish, the growth of coral, the feeding of birds. The pull of the moon regulates not just oceans, but the internal tides of living things. Even the rhythm of our hearts echoes the cadence of planetary motion, systole and diastole, contraction and release, miniature reflections of cosmic breathing. We are not separate from the universe's motion. We are expressions of it, moving in the same endless flow. More than motion, it's the planet's pulse. Gravity transmits energy through water, crust, and atmosphere, creating a vibration that connects every shore and every current. The tides are Earth's way of feeling the cosmos, its surface rising and falling in sync with celestial bodies. Each wave that returns to the sea is a heartbeat measured in spacetime, a reminder that even our planet participates in the universal dance. Every sunrise, every orbit, is gravity at work. The sun rises because Earth spins, and Earth spins because gravity shaped it that way, compressing dust into a sphere that learned to rotate as it formed. Our orbit, stable and precise, keeps the seasons turning and life sustained. Each sunrise is a product of geometry and attraction, light and curvature in harmony. The warmth on your face each morning is not just sunlight. It's gravity's consequence, the continuity of motion set billions of years ago. Every dawn is a quiet proof that the cosmos remembers how to balance. An architecture built by falling. Every structure in the universe, from raindrops to galaxies, is built through falling. Matter falls inward under gravity, compresses, and stabilizes. Stars ignite from collapsing clouds. Planets condense from falling dust. Even the graceful arms of galaxies are patterns carved by continuous descent. Falling is not failure. It's formation. The universe is built by surrender, by matter giving in to gravity's curve. And in that fall, order emerges. The cosmos is not held together by resistance, but by acceptance. Everything finding its rightful place through motion. Curvature in motion, not chaos. When you look at the night sky, the vastness might seem chaotic, countless stars scattered without pattern. But beneath that appearance lies perfect curvature in motion. Every orbit follows an equation. Every galaxy obeys geometry. Gravity ensures that nothing drifts aimlessly. The universe's structure is not random, but sculpted by invisible curves. What we call chaos is only complexity, billions of motions, all harmonized by the same rule. Gravity doesn't eliminate disorder, it transforms it into dance. It is not control, but coherence. Gravity, the artist of dust and stars. In its patience, gravity is the universe's greatest artist. Its brushstrokes are slow, its canvas infinite. Ongoing masterpiece. Over billions of years, it refines its work, turning chaos into composition. When you gaze into the Milky Way, you are looking at art drawn not in color or sound, but in curvature. Gravity is creation expressed through time, the silent architect of everything. From the universe's architect, quiet, invisible, tireless. It builds with patience, sculpts with precision, destroys only to rebuild. It is the force that unites opposites, chaos and order, motion and stillness, birth and decay. Every structure, every orbit, every moment of existence is its work. And though we cannot touch it, we feel it always, the weight beneath our feet. The orbit of our world, the balance of the stars. Gravity is the silent architect of eternity. Light bends, not because of mass, but because of geometry. Light always travels straight, but straightness depends on geometry. When space-time curves around a massive object, light follows that curvature naturally. It doesn't feel gravity the way matter does. Instead, it glides along the warped paths of the universe itself. Imagine a ray of light as a dancer tracing the lines of a moving stage. She never changes direction, but the floor beneath her shifts and sways. This truth, that space itself is the lens through which light must travel. Gravity tells light which path to take. In Einstein's universe, gravity doesn't pull light, it instructs it. The presence of mass shapes the rules of motion, and light obeys them without resistance. A beam passing near a star, a black hole, or even a galaxy finds its path altered, not by tug, but by terrain. Space is not empty, it has contours. Light, being massless, is the perfect messenger of those contours. When it changes direction, it is simply reading the geometry aloud. Every ray of starlight we see is a record of space-time structure, a signature of gravity written in radiance. Around massive objects, photons follow curved lines. A photon leaving a distant quasar travels, has danced through countless invisible valleys. Einstein rings, the halos of warped light. Sometimes, when a distant galaxy aligns perfectly behind another, the light from the background object bends symmetrically around the foreground mass, forming a glowing circle called an Einstein ring. It's a natural consequence of relativity, a cosmic halo of bent light. To the eye, it looks like a sacred symbol, a ring of fire suspended in space. But to physics, it's pure geometry made visible. The foreground galaxy acts as a gravitational lens, curving space-time enough to focus the background light. The universe becomes capable of seeing itself. Light from distant galaxies can wrap around others, showing us multiple images of the same object, sometimes mirrored, sometimes stretched. The cosmos turns reflective, each galaxy a mirror for another's light. When astronomers look deep enough, they sometimes see repeating patterns, arcs, rings, duplicates of galaxies billions of light years away. This is an illusion, its reflection on a cosmic scale. Gravity has turned space into a hall of mirrors, and through those reflections, the universe admires its own form. Black holes create gravitational mirages. Around black holes, light bends so sharply that it can orbit them multiple times before escaping. The result is a shimmering halo called the photon sphere. From the outside, we might see multiple images of the same star, twisted and stacked around the darkness, a gravitational mirage. The Event Horizon Telescope captured one of these in 2019. A glowing ring encircling the shadow of a black hole in galaxy M87. What we see there is not the black hole itself, but light warped around it. Reality turned inward by geometry. The black hole doesn't emit light, it shapes it. It turns brightness into orbit, motion into art. Seeing galaxies behind galaxies. Through gravitational lensing, astronomers have seen galaxies that would otherwise be hidden, their light magnified and bent by clusters in front of them. Some of the farthest galaxies ever discovered were revealed this way, their faint light stretched into visibility by gravities. Deeply linked, one defines the other. Where gravity slows time, it also bends light. The two distort in unison, each responding to the curvature of spacetime. Near massive bodies, light's frequency shifts, its color reddens as time stretches. This connection is profound. It means that when we study light, we are also studying time. Every photon carries a timestamp, its frequency a record of the temporal landscape it has crossed. The light we see tonight is not just illumination, it's history, compressed into vibration. Gravitational redshift, stretching the color of time. When light climbs out of a gravitational well, it loses energy, not by slowing down, but by stretching its wavelength. Its color shifts toward red, the lower energy end of the spectrum. This gravitational redshift is one of Einstein's most striking predictions. It has been confirmed in stars, white dwarfs, and even by atomic clocks on Earth. The redshift is not illusion. It's light paying a toll to escape. Light loses energy. Imagine light as a traveler escaping a deep valley. It doesn't slow, it can't, but it changes as it climbs. Each wave becomes longer, softer, redder, carrying away less energy. Per crest. This is how light tells us about the depths it has passed through. From the sun to the edge of the universe, photons bear the fingerprint of every gravitational well they have crossed. In their stretching, they reveal the architecture of spacetime. To look at redshifted light is to read a map of the universe's curves, an atlas drawn not on paper, but on color itself. Every photon ages differently across curvature. A photon traveling near a massive body experiences time differently than one far away. In relativity, even massless light has its own form of temporal experience, a kind of geometric aging. Its frequency changes, its phase shifts, its wavelength stretches, all depending on the gravitational fields it encounters. The light from stars orbiting close to a black hole is older in color than that from stars farther out. In this way, photons carry records of time itself. The night sky is a gallery of ancient clocks, each beam a different measure of. Near black holes, it becomes captive, spiraling inward until it vanishes beyond the horizon. And yet, the same geometry that can trap light can also magnify it, bending distant galaxies into brilliance. Gravity is both prison and lens, both shadow and revelation. It chooses no side. It simply curves space as it must. Light's freedom and confinement are two aspects of the same truth. That even radiance must follow the shape of time. The cosmic microwave background bears gravity's imprint. The oldest light in existence, the cosmic microwave background, has been traveling for 13.8 billion years. Along its journey, it passed through countless gravitational fields, each leaving tiny distortions. These faint irregularities, measured by satellites like Planck and WMAP, reveal the universe's structure when it was only 380,000 years old. The slight warping of this ancient light is gravity's fingerprint across eternity. It proves that spacetime's curves have shaped. It immediately began weaving through gravitational hills and valleys. Every fluctuation in density bent its path, stretching and focusing it into the faint cosmic glow we see today. Of the cosmos, the light that began its journey at creation still carries the imprint of those early bends, the first reflections in the mirror of spacetime. Every starbeam is bent by the cosmic. Every beam is slightly bent, delayed, and stretched by the geometry it passed through. What you see as a straight line is, in truth, a spiral through the unseen contours of spacetime. Each point of light is the sum of billions of small deflections, all adding to the shimmering tapestry of the night. You are seeing not the stars as they are, but as gravity has painted them. The night sky is spacetime's artwork. Every glowing point above you is part of a vast painting, not drawn by hand, but by curvature and light. The stars, their colors, their positions. Space as canvas, time as brushstroke, light as pigment. The universe is not simply seen, it is performed, an endless collaboration between motion and illumination. To gaze at the stars is to watch. We would never see the cosmos. Without gravity, there would be nothing to see. Together, they weave the story of reality, one speaking in photons, the other in curves. Every telescope, every equation, every act of wonder is an attempt to listen to both voices at once. The beauty of the cosmos lies not in one or the other, but in their duet. Illumination dancing upon structure. Creation revealed through shape. One reveals, one shapes. If gravity is the sculptor, light is the storyteller. Gravity molds the galaxies, carves the black holes, stretches time. light escapes those. One builds the world, the other describes it. The stars are gravity's architecture illuminated by light's narrative. The universe, then, is both sculpture and story, matter and motion, made meaningful by radiance. Together they weave the visible and the invisible. Light and gravity are two sides of one tapestry. Gravity defines the invisible threads, the structure, the geometry, the silent framework, while light fills it with color and warmth. When we observe the night sky, we are seeing both at once. The visible woven through the invisible, the galaxy's shapes, the rings of lensed light, the shadows of black holes. All are products of their cooperation. Even darkness shines, in its own way, through the curves it casts upon light. The cosmos is not made of, and light in dialogue. Every photon is a word, every curve a gesture. Together, they compose a cosmic conversation that spans all time. When you look at the sky, you are witnessing that exchange. Light telling the story that gravity has written. The stars are sentences, galaxies are paragraphs, and space itself is the page. This dialogue has no end, no beginning. It is the eternal whisper. Between geometry and glow, the language through which the universe expresses itself. Gravity resists quantization. Einstein's theory of gravity is beautifully smooth. It treats spacetime as a continuous fabric, curving, stretching, rippling without edges or breaks. But quantum mechanics sees the world differently, as discrete, jittering, made of probabilities and jumps. Continuity over quantization. The universe's largest force remains the most elusive at its smallest scales. The universe at small scales is grainy. If you could zoom in beyond atoms, beyond quarks, beyond the known particles, you'd reach a trembling threshold, a world where certainty dissolves. Space itself begins to flicker. Time hesitates. The smoothness we perceive becomes pixelated, jittering like static. In this realm, called the quantum domain, nothing sits still or behaves predictably. Energy pops in and out of existence. Particles appear, vanish, and reappear somewhere else. This graininess defines reality at the Planck scale, where the universe stops being continuous and becomes dynamic, a frothing sea of possibilities. Beneath every steady surface lies quantum turbulence, unseen but eternal. The Planck length, edge of certainty. There is a smallest meaningful distance in the universe, the Planck length, about 1.6 times 10 superscript 3 meters. Smaller than this, the very idea of space breaks down. Geometry ceases to exist in any familiar way. It's the boundary where gravity and quantum mechanics collide, where curvature becomes probability. At this scale, space-time may no longer be fabric, but foam, constantly forming and dissolving. The Planck length isn't just small, it's fundamental, a natural limit to knowledge. Beyond it, questions like where, constant fluctuation, quantum foam. At unimaginably small scales, space and time bubble and twist, forming tiny tunnels, loops, and momentary geometries. The smooth universe we see is like the calm surface of this deeper chaos. Every atom, every photon, every wave of gravity rises from this invisible churn. The foam is not disorder, but potential, an endless dance of emergence and collapse. Again and again, gravity may emerge, not exist fundamentally. Some physicists believe gravity is not a fundamental force at all, but an emergent phenomenon, a large-scale effect that arises from the collective behavior of quantum systems. Just as temperature emerges from the motion of atoms, curvature might emerge from the entanglement of quantum information. In this view, spacetime itself is not built in from the start. It appears when enough microscopic connections align. Gravity, then, would be a kind of statistical illusion, a macroscopic byproduct of countless quantum relationships. What we feel as attraction might just be the universe's natural way of preserving balance among its smallest truths. Entanglement and curvature. Quantum entanglement, the mysterious link that binds countless interactions, and you get a network of relationships dense enough to resemble space itself. The pattern of entanglement could determine how space-time bends and curves. In this sense, tapestry woven from connection, space woven from quantum threads. Imagine space-time as a vast fabric woven from threads of quantum interaction. Each thread is a connection, a link of entanglement. Isn't truly empty. It's filled with an invisible textile of connectivity, stretching and flexing with every cosmic breath. Each vibration becomes geometry. In quantum theory, everything is vibration. Waves of probability, oscillating fields of energy. If gravity arises from these vibrations, then space-time itself might be a standing wave, a pattern of frequencies resonating across scales. Every fluctuation of a field translates into a tiny shift in curvature. Geometry, then, is music, the song that energy sings to define structure. Matter is the melody, space is the harmony. Relationships tightens around mass and energy. You feel it as weight, but it may simply be structure, a reminder that everything is linked. What keeps your feet on the ground may not be force, but participation in the universe's collective geometry. Wormholes, quantum shortcuts. Wormholes, the tunnels that connect distant regions of space-time, may arise naturally from quantum entanglement. Some physicists propose that every entangled pair of particles is connected by a microscopic wormhole, a bridge that encodes their shared information. These tunnels are unimaginably small, collapsing instantly, yet their existence could hint at a deep unity between geometry and information. On cosmic scales, larger wormholes might form through the same mechanism, connecting galaxies or spacetime. If wormholes exist, they could allow information to move through spacetime in ways we don't yet understand. Some might transmit data instantaneously through quantum links. Others could bridge vast distances across the cosmos. Even if no object can cross them safely, the idea remains profound. Information might not be confined to linear time or distance. In a universe where entanglement weaves geometry, knowledge itself can flow through invisible channels. Gravity may not only shape where matter goes, it may decide how information travels, binding thought and structure in the same silent network. Quantum gravity, the dream of unification. Physicists have long sought a single framework that unites the vastness of relativity with the minuteness of quantum theory, a theory of quantum gravity. String theory, loop quantum gravity, and holographic models are all attempts to reconcile smooth curvature with granular uncertainty. The challenge is immense. How can space-time, continuous and elegant, emerge from a world built on probabilities? And yet, glimpses appear in black hole thermodynamics, in entanglement entropy, in the subtle shimmer of gravitational waves. The dream of unification persists because it feels inevitable. The universe cannot remain divided between the large and the small forever. The holographic principle, a map of everything. The holographic principle proposes that all the information in a region of space can be described by data stored on its boundary. This means that reality, as we experience it, may be a projection of a lower dimensional code. Every star, atom, and moment could be encoded on a distant surface, like the image in a hologram. In black holes, this principle holds precisely. Their entropy, a measure of information, depends on surface area, not volume. The same idea might apply to the entire cosmos. The universe may be a vast information. They found that their entropy was proportional to the area of their event horizons. This connection revealed something profound. Gravity might arise from changes in information on surfaces, the way entropy balances across spacetime. In this view, Einstein's equations describing curvature can be derived from simple thermodynamic principles. Gravity becomes not a force, but a tendency toward equilibrium. The universe forever seeking balance in its own information flow. Black holes as the universe's memory banks. Black holes, once thought to erase everything, may in fact be perfect. Existence. They are the universe's hard drives, silent, absolute, and nearly eternal. The cosmos forgets nothing, it only hides its data in the dark. Every particle carries gravity's signature. Even shaping of reality. The small and the vast are never truly separate. Each atom bends the cosmos, and the cosmos defines each atom's path. Mass as frozen energy, energy as curved geometry. Einstein's equation, E equals mc squared, tells us that mass and energy are the same thing, two expressions of one principle. But general relativity adds a deeper layer. Energy doesn't just exist, it shapes geometry. Information, it learns, adjusts, and refines its patterns. Galaxies, stars, and life may be expressions of that self-awareness, structures through which the cosmos observes its own geometry. Consciousness, then, would not be separate from physics, but a continuation of it. The universe dreams in equations, and we are those dreams given form. Every observation, every act of curiosity, is the universe reflecting on its own design. Gravity as the geometry of consciousness. If information and structure give rise to spacetime, then awareness might be another layer of that same geometry. Consciousness could be what gravity feels like from within, the internal experience of connectivity. Just as spacetime curves to hold matter together, awareness might curve to hold thoughts and perceptions in unity. Both are self-organizing, self-sustaining, and relational. Perhaps the line between physics and mind is not a boundary, but a mirror. Gravity binds matter. And thought may not be separate things, but different expressions of the same underlying principle, structure seeking coherence. The geometry of spacetime, the flow of awareness, the unfolding of. The two meet where existence becomes aware of itself. The whisper of the quantum world and the curve of the cosmic one are echoes of the same origin, the quiet unity behind all that is. Gravity began with wonder, not equations. Long before we could measure it, we could feel it, the downward pull that gave shape to walking, to falling, to dreaming. When an apple fell, it was not just a fruit returning to the earth, but the first question whispered into human thought. Why? From that simple wonder came centuries of discovery, until Einstein revealed that we were, not through violence, but through belonging. The universe is one because gravity never forgets to hold. To fall is to belong to the universe. Falling is often feared, but in truth, to fall is to participate. Every object that moves freely, a feather, a planet, a human body, is simply following the natural curve of spacetime. To fall is not to be pulled, but to be aligned with the flow of. Through the orbit of Earth, through the motion of the galaxy. To fall is to belong completely, to let go, and still be held. We are held, not trapped, by its embrace. It's easy to think of gravity as confinement, a force that keeps us bound to the ground. But that's a misunderstanding born of perspective. Gravity is not a cage, it's a cradle. It doesn't imprison, it supports. The same curvature that holds you to Earth allows the Earth to circle the sun and the sun to dance through the galaxy. Every orbit is freedom within balance. Without gravity, there would be no direction, no anchor, no harmony. To be held by gravity is to be in conversation with the cosmos, balance between flight and fall, between motion and rest. The Earth's pull is also its affection. We often measure gravity in numbers, 9.8 meters per second squared, but beneath the equation lies a quiet tenderness. The Earth is not pulling us out of greed, but out of connection. It holds the oceans close. Not just weight, but relationship, the planet acknowledging your presence, saying, "You are part of me." In every sense that matters, gravity is affection expressed through geometry. Every step is a conversation with spacetime. Each time you take a step, you are not only moving through space, you are bending time, ever so slightly. Your mass curves spacetime around you. This is true of every creature, every cloud, every atom. To move is to speak the language of gravity, one footstep at a time, one heartbeat at a time, one orbit at a time. Every heartbeat echoes against cosmic curvature. Even the rhythm of your heart participates in the geometry of the universe. Each pulse slightly disturbs the spacetime around you, a microscopic ripple spreading outward at. Gravity gives meaning to down. Down is not a direction, it's a relationship. It means toward the center, toward the heart of what holds you. Every planet defines its own down, every star its own center. There is no universal downward, only countless local meanings of belonging. Gravity gives orientation not only to bodies, but to purpose. The idea of ground, of stability, of home, exists because of it. Even the notion of falling in love borrows its language from gravity. To move downward is to move inward, toward connection. Down is not fall, it is return. We live inside the geometry of existence. You are not standing on spacetime, you are inside it. Every breath you take, every movement you make, every thought you think occurs within the folds of escape. Even dreams are bound by invisible arcs. When you dream of flying, of floating, of drifting through unknown skies, gravity does not disappear. It changes form. It becomes metaphor, symbol, rhythm. Even the dream follows curves, upward, downward, circling through imagined space. Your sleeping mind mirrors the cosmos, generating motion within stillness. The same neural waves that create imagery echo the same mathematics that governs galaxies. You are never truly free from gravity, nor should you be. Even in dreams, the universe continues to hold you, gently, as if to remind you that every freedom needs its frame. Our atoms will drift, but never leave. Someday, your body will dissolve, your molecules scattering into the air, the ocean, the soil. But they will not vanish. Each atom will continue its journey, drawn by the same gravitational curves that once held you. Some may join clouds, others drift into space, perhaps to be caught in the pull of a star yet to be, to fall again into stars and sky. Every element in your body, carbon, iron, oxygen, calcium, was forged in the heart of ancient stars. When those stars exploded, gravity gathered their ashes into keeper of form. It is the recycler of eternity. Every fall leads to a new beginning. You are stardust now, and someday, you will be stardust again, falling forever into new light. The universe remembers every orbit. No motion is ever truly lost. The spin of a planet, the fall of a meteor, the orbit of an electron, all leave faint imprints in the geometry of space-time. The universe records every trajectory, every vibration, in its curvature. Memory, in the cosmic sense, is not kept in words or symbols, but in shape, the accumulated texture of all that has moved. In this way, gravity is history written in geometry. Every orbit is a sentence, every revolution a story. The universe remembers through motion, and you, too, are part of that ongoing remembrance. Gravity is memory made into motion. Think of every orbit, every wave, every heartbeat. They are all echoes of earlier motion. Gravity keeps the past alive, translating what has been into what is. The moon remembers the pull of Earth. The Earth remembers the pull of the sun. Each revolution is a retelling, an echo of the original movement that began it. In you, the same principle holds. Your body remembers gravity's teaching, even as you walk. It guides your balance, your sense of space, your instinct for center. Memory, it seems, is not just in minds, it is in the motion of the together so that 1 second can follow another, one atom can meet another, one heart can beat again. It bridges the finite and the infinite, the visible and the unseen. Through gravity, the universe expresses permanence, not as stillness, but as rhythm. Every orbit, every wave, every pulse is a step on that bridge between being and forever. It is not eternity as immobility. No arena for life to evolve. The equations may seem abstract, but they describe the most intimate truth, that we live inside a vast, invisible architecture designed for experience. Gravity doesn't dictate the play, it builds the theater, and then lets everything dance. To feel it is to feel the shape of time. When you feel your weight, when you notice your body resting against the ground, you are sensing more than force. You are feeling the curvature of time itself, the slow descent of moments through the field of existence. Gravity is not separate from time. It is time made tangible. Every step downward is a movement through both space and duration. To feel gravity is to feel the universe aging gently around you. Each moment carries you forward in the same way Earth carries you. Around the sun, a journey through the invisible contours of now. You are part of the curve. You are not outside the universe, observing it. You are within it, a curve in its geometry, a note in its resonance. You in return. The connection is mutual, inseparable. To live is to be curved, to participate in the ongoing shaping of reality. You are not apart from the cosmos. You are one of its shapes. Constantly, carrying you like a river carries a leaf. What we call gravity is simply the current of time and geometry moving together. You are never separate from that flow. You are made of it. The universe does not happen around you. It happens through you. In that fall, everything finds its place. And so we return to where we began. The simple act of falling, the quiet certainty of being. Held. Every star, every planet, every grain of dust is suspended in the same motion, endlessly falling, endlessly belonging. There is no edge, no outside, no end. The universe folds upon itself. Complete, alive, and continuous. Gravity is not a force but a promise that nothing is truly lost, only transformed. To fall is to return. To be curved is to be connected. And in that infinite, gentle descent, everything finds its place. And now, we have reached the end of our journey. Through curves and orbits, through waves and whispers, through the quiet architecture that holds all things together. Gravity has guided us, not as. The same gravity that guides comets and moons is holding your breath, measuring your heartbeat, carrying your dreams gently across the curve of night. You don't need to reach or understand anymore. You are already part of the pattern. The same equation, the same flow, the same fall. Let the universe keep falling through you. Let its silence fill the space behind your thoughts. Let time stretch softly, until there is no before or after, only this stillness. This moment suspended in the fabric of everything. Sleep, now, not apart from the cosmos, but within it. Because you were never just under gravity. You are gravity, a ripple of existence in the quiet curve of eternity. Good night, traveler of spacetime. May you fall gently into the infinite.